Get some examples from your packet where you were given a rule, an A sub n or a formula, and you had to generate a list of terms. Now we're going the other way. And we've got a list of terms, and we have to figure out the nth term. And anytime you're asked to figure out the nth term, you're really trying to figure out the rule for A sub n. So here's a strategy that you might want to try. I'm going to make a chart, like a t-chart, kind of like if you were graphing with an x and a y, except we're going to have an n and an a sub n. And for my values of n, remember they're the counting numbers, so 1, 2, 3, 4, 5, dot, 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 and then we're going to have an n. And then I'm going to list my terms. I have a 1, a 3, a 5, a 7. And you can think about what would be next. Well, hopefully you see that it's going up. You add 2 each time. You add 2, you add 2. So next, is going to be a 9. But we have to come up with a rule. So if you are adding, now, first of all, you could actually plot these points. And if you were to plot these points, you're going to notice they're in a line. And your line has a slope of 2 because we're adding that constant each time. So we need to come up with an expression that has a slope of 2. So 2n. And now you want to, and you can do a little bit of guess and checking, because obviously if I plug a 1 in, I get 2, I don't get 1. If I plug a 2 in, I get 4, and I want 3. Well, notice that I'm always getting 1 more than what I want. So if I subtract 1, and then test it. So plug a 1 in for n, and you get 2 times 1 minus 1 is 1. Then plug a 2 in. 2 times 2 is 4, minus 1 is 3. Plug a 3 in. And then after you've convinced yourself it works, then we know that this is my answer for the nth term. So that would be the pattern or the rule. So on this one, I'm going to do the same thing. So I'm going to have n and a sub n. So n are counting numbers. And we're going to end with an n because that's our expression. I didn't write it down there. So we have 2, 4, 8, 16. And you probably can guess what would be next, because look what's happening. I'm multiplying 2 times 2 to get 4, and then times 2 again to get 8, and times 2 again to get 16. So we know this is going to be 32 because I multiply by 2 again. Well, these are powers of 2. Notice that 4 is 2 squared. 8 is 2 cubed. 16, 2 to the 4th. 32, 2 to the 5th. It works here too because 2 is 2 to the 1st. Look at my powers. They're the values of n, which means this answer for a sub n would be 2 to the nth power. And again, you can double check that it works for all your numbers, and then until you're convinced that you've got the correct answer. So same set of directions, same kind of set of problems, because these are a little tricky. So I have n, I have a sub n. Again, n is the counting numbers. And here I'll list my terms in the sequence. So I need to find what the pattern is. Well, hopefully you see -2 plus 5. If I add 5, I get 3. If I add 5, I get 8. If I add 5, I get 13. So once again, we have this adding 5 over and over again, which tells me if I plotted these points, they would look linear, which means when I'm looking for my rule, it has a slope of 5. So I'm going to say 5n. And then I just need to figure out what I need to do to that, because 5, again, using the first number, 5 times 1 is not -2. So what would I have to do, because 5 times 1 is 5. If I wanted to get to a -2, notice I can subtract 7, because 5 times 1 is 5, minus 7 is -2. Now I'm going to test it. 5 times 2 is 10, minus 7 is 3, so it works. 5 times 3 is 15, minus 7 is 8, so it works. So now I'm convinced that this is my rule for a sub n. All right? So you notice that I kind of, it's not completely, guess and checking, but I'm using a little bit of that. So we have our natural numbers. And I'm going to put my values in here. So 3.3, 0.03, 0.003. Probably you'd figure out what would be next, 0.0003. Now you might have a little harder time because you might think, well, I'm just moving the decimal point one place. But think about what that means. If you are moving the decimal point one place to the left, then you are dividing by 10, or you could say multiplying by 1/10. Okay, so I know I'm multiplying by, I'm going to use that, multiplying by a 10th. But I know I start with a 3, and I'm multiplying by a 10th. But I got to have an n in there somewhere. So let me try this. What if I put an n here? Well, if I plug a 1 in for my n, 3 times a 10th is 0.3. Well, I want it to be 3. I don't want the 0.3 until I get here. So I need to adjust this in. So what I'm going to do is subtract 1 from it, and then I'm going to try again. So if I plug in a 1, 1 minus 1 is 0, and anything to the 0 power is equal to 1, times 3 is 3, so the first one works. If I plug in a 2, I get 1/10 to the first power, which is a 10th, times 3, which is 0.3. And then you can check it for the third one. So notice how, I kind of started off with the idea, but not knowing that it would be an n minus 1 until you kind of did a little bit of guess and checking. So I'm going to write this out as a sub n equals 3 times 1/10 to the n minus 1. Now, where I talked about how this was linear, look at this one. A number times something to a power. So this looks rather exponential. The big difference on here would be if you plotted these points, you would not connect the dots because n can't be a fraction or a decimal. It can only be counting numbers. Same thing would be true on this, but they do follow either a linear pattern or an exponential pattern, and we're going to see more of these in some upcoming sections in our textbook. So I like this one. So this is the last one I'm going to do. So if we have n and a sub n, so we have 1 3/4, 5/9, 7/16, 9/25, etc. And we have to figure out the pattern. Well, first of all, I'm going to write this one as 1 over 1 because there's two patterns going on. First, just look at the numerators. If you look only at the numerators, you'll see that it's a 1, a 3, a 5, a 7, so you're adding 2. Well, we saw what kind of pattern, that's kind of a linear pattern. So then for my numerators, we're going to have 2n, but I need it to be the first, plugging in a 1, I need it to be a 1. Plugging in a 2, I need it to be a 3. So I'm going to have to subtract 1 from that. And then double check. So 2 times 1 is 2 minus 1 is 1. So I'm getting the first numerator. 2 times 2 is 4 minus 1 is 3. So I get the next one. 2 times 3 is 6 minus 1 is 5. So I get the next one. So this works for the numerators. Now look at the denominators. Well, I've got a 1, a 4, a 9, a 16, a 25. That's a special pattern. Notice they are all perfect squares. So for the first one, it's 1 squared, 2 squared, 3 squared. So it looks like it's just the value of n. 4 squared is 16, 5 squared is 25. So it looks like we have n squared for the denominators. So then put those together. A sub n is 2n minus 1 over n squared. So when you have kind of a strategy to organize your terms, it's not so bad. But this probably, from your homework from this section, the ones like this might be the toughest for you, but I think this is a good strategy for you to try.